Every successful person you admire today didn't succeed because the problems was easy for them. They succeeded because when a problem showed up, they made a decision not to complain, not to blame, not to quit, but to find a solution. That's what makes the difference. A problem is just a signal, it tells where something is not working. But too many people spend all their time describing the problem in vivid detail. Don't waste your energy repeating what's wrong. Challenge your energy on what can go right and choose what you do next. And start investing time in finding the next move. That is the idea which I'm going to give you today to all my viewers. And today's topic is on chi-square test of independence of attributes. So this is the second model on chi-square test. So here, what is this attribute? Literally, an attribute means a quality or a character. Example of attributes are drinking, smoking, blindness, honesty, beauty, etc. Clear? An attribute may be marked by its presence or absence in a number of a given population. Let the observations be classified according to two attributes, and the frequencies OI in the different category be shown in the two-way table. So there will be a two-way table here called contingency table. We have to test on the basis of cell frequency whether the two attributes are independent or not. So we take, as usual, we take the first step as null hypothesis. Null hypothesis, that is, we assume that the two attributes are independent. And the next one is alternate hypothesis. We assume that the two attributes are not independent. And the next one is, here is an important formula, that is expected frequency. So I'll show you, in order to find the expected frequency, there is a formula here. So which is very, very important here, row total into column total by grand total. And the next one is, as usual, the fourth step is test statistics. The for test statistics chi-square is sigma OI minus EI whole square. So whole square by EI. So here is the test statistics formula, and the next one is degrees of freedom. So number of rows minus 1 into number of rows minus 1 gives you the degrees of freedom. So here is the level of significance. If you calculate, if the calculated value chi-square, so if chi-square is less than the tabular value at 5% level of significance, then the hypothesis holds good. And if the chi-square value is greater than the tabular value, then we say that. So here, if chi-square value is greater than the tabular value at the specified level of significance, we say that the results of the experiment do not support the hypothesis. In other words, the attributes are associated. So this is how we have to take the 5 steps, and see here they are attributes means drinking, smoking, blindness, honesty, beauty, etc. It depends upon the characteristic or the quality here. So here is the first problem related to chi-square test of independence. So this is example 1 here. On the basis of the information given below about the treatment of 200 patients suffering from disease, state, and now we have to state whether the new treatment is comparatively superior to the conventional treatment. So here we have to state whether the new treatment is comparatively superior to the conventional treatment. Here is the new treatment and here is the conventional treatment. So the favorable, not favorable, total here. So these are the rows. The rows are 60, 30, and next one 40, 70. The columns are 60, 40 and 30, 40. Immediately we have to take the grand total here. So 60 plus 30 is 90 and 40 plus 70 is equal to 110. And now we have to make a total here. So this value is equal to 100. So this is column total and this value is again 100. So if you add up, the grand total will be, see here, 90 plus 110. So here is the grand total, which is equal to 200. Clear? 100 plus 100 is equal to 200, and again 90 plus 110 is equal to 200. And next one, see here, every time we have to use the 5 steps. First one is the null hypothesis. No difference between the new and the conventional treatment. The new and the conventional treatment are independent. So we have taken it as an independent. The degrees of freedom here is n minus 1. Number of rows minus 1 and number of columns minus 1. So there are 2 rows here and 2 columns here. So here 2 minus 1. 1 into 1 is 1. So here we have the degrees of freedom as 1. So after that one we have to take the null hypothesis. So there is a difference between the new and the conventional treatment. And this is the table we got. And see here, so first one is, so the favorable chi-square test of independence of attribute. So this is the new treatment and this is the conventional treatment. So these are the columns from the question itself, that is 60, 30, 40, 70. Clear? So this is a 60, 30 and 40, 70. So we have to make a total here. So this is 60 plus 30 is 90 and 40 plus 70 is 110. And here this is the column total 100. This is the column total and this will be the grand total. So this is the grand total. As I have shown you a formula here. So for expected frequency. So this is the expected frequency. Sorry. This is the expected frequency for each and every value here. So expected frequency is nothing but row total into column total divided by grand total. Clear? Row total into column total. So what is row total here? Row total is 90. Column total is 100 divided by grand total. For this position, so we have to write as row total into column total by grand total. The value here is 45. And for this one also, row total is 90 and column total is again 100 into divided by grand total, it is 200. The value is 45. And the next one for this 40 also. So here the row total is 110. So this is 110 and the column total is 100 divided by grand total is 200. The value is 55. And the next one here for this position, the row total is 110 into the column total is 100 divided by grand total. This is 200. The value is 55. So for each and every value, so this is the frequency and this is the expected frequency, and therefore again I am making a total 45 plus 45 is 90, 55 plus 55 is 110, and here 45 plus 55 is 100 and 45 plus 55 is 100, and this is the grand total. And now how to calculate this chi-square test? So as usual, so these are all the observed values. The observed values from the table is 60, 30, 40, 70. See clear? 60, 30, 40, 70 in the first row, in the first column, and the next one here the values are 45, 45, 55, 55. These are the expected frequency. Expected frequency are 45, 45, 55, 55. And now we have to make a difference and make a square. 60 minus 45 is 15. 15 square is 225. 30 minus 45 is minus 15 whole square is 225. 40 minus 55 is minus 15 whole square is 225, and 70 minus 55, that is 15, which is equal to 225. Now we have to make a division here, that is 225 divided by EI. So what is EI? 45. 225 divided by 45 is 5, and 225 divided by 45 is 5. 225 divided by 55 is 4.09, and 225 divided by 55 is 4.09. So this is 4.09. So we have to make a total here. So this will be sigma OI minus EI whole square by EI. So the value here is 18.18. Clear? So after getting, so this is the calculated value for chi-square test of goodness for attributes. And the next one is the degrees of freedom. Here is very clear, as I'm going to show you, as this is 18.18. So from the textbook also this is 18.18. So I made the calculations there. And the next one is the degrees of freedom. So the degrees of freedom here is very clear as number of rows minus 1 into number of columns minus 1. So here the degrees of freedom is number of rows minus 1. There are 2 rows here and 2 columns here, and this value is 1. So, and now we have to see a chi-square test. So for chi-square test for 1 at 5% level of significance is 3.841. So 3.841 we got at 1% significance. So at 1% significance we got, see here for chi-square, the tabular value of 1 at 5% degrees of freedom is 3.841. And therefore this is the calculated value and this is the tabular value. And since the calculated value is greater than the tabular value, we are going to reject the null hypothesis. We are going to reject the null hypothesis H0. And that is, the new and the conventional treatment are not independent. The new treatment is comparatively superior than the conventional treatment. And this is the final conclusion which we got, as the calculated value is greater than the tabular value, and we are going to reject the null hypothesis, and we have a conclusion that the new treatment is comparatively superior to the conventional treatment. And here is a second question here. The following table gives the classifications of 100 workers according to the sex and the nature of work. Test whether the nature of the work is independent of the sex of the workers. The first one is males. See here, this is female and this is the grand total. Stable, unstable. This is the total here. So these are all the values here, that is 40, 20, 10, 30. So we have to make an addition here. So this is 40 plus 20 is a 60, and next one 10 plus 30 is nothing but 40, and see here 40 plus 10 is 50 and 20 plus 30 is 50. Immediately we have to make a total here, and this will be the grand total, that is 60 plus 40 is 100 and 50 plus 50 is again 100. So here we have to take 5 steps here. So we have to calculate the expected values also. So here 40, 20, 10, 30. So this is 40, 20, 10, 30. So these are stable, unstable, this is total, and this one is a grand total. So here, this is the grand total. And see here, we have to find the expected frequency. For expected frequency, the formula here is the row total into the column total divided by the grand total. See here, what is the row total here? 60. And what is the column total here? 50. 60 into 50 divided by the grand total here. This is the grand total, which is equal to 100. 60 into 50 divided by 100, the value is 30. And the next one, for this position, the row total is 60 and the column total is 50. 60 into 50 divided by grand total is 100. The value is 30. And for this 10 also, the row total is 40 and the column total is 50. See here, 40 into 50 divided by grand total is 100. The value is 20. For this position, the row total is 40, column total is 50 divided by grand total. That is 40 into 50. 40 into 50 divided by 100. The value is 20. Immediately we have to take the addition here. 30 plus 30 is 60. 20 plus 20 is 40. And here 30 plus 20 is 50. And 30 plus 20 is 50. And the grand total here is 100. And this is 100. And see, these are all the observed values, observed frequency values, and these are all the expected frequency values. And now according to our formula here, the calculation for chi-square. So here are the observed values. So observed values are 40, 20, 10, 30. Clear? 40, 20, 10, 30 in the first column, and here 30, 30, 20, 20 in the second column. And next one, we have to make a difference and make square. That is 40 minus 30 is 10, 10 square is 100. 20 minus 30 is minus 10, whole square is 100. 10 minus 20 is minus 10, whole square is 100. 30 minus 20 is 10, whole square is 100. And now see here, this whole square divided by EI, that is 100 minus 30, 3.333. 100 minus 30, 3.333. 100 minus 20 is 5.0 and 100 minus 20 is 5.0. And therefore, the total here is 16.66. And therefore, this is the total here. That is chi-square value is sigma OI minus EI whole square by EI, that is 16.66. So after the test statistics, now we have to go with the degrees of freedom. So for degrees of freedom, see here as usual. So for degrees of freedom, let me show you. This value we got as 16.66. Just now we have calculated. For degrees of freedom, the number of rows minus 1 into the number of columns minus 1. So here the rows are 2 and the columns are 2. And therefore 1 minus 1, the value here is 1. At 1 degrees of freedom, see here at chi-square result, at degrees of freedom 1 at 5%, that is 0.05, that is 3.841 is the value. At 5% level of significance, 3.84 is the value. So this is the calculated value and this is the tabular value. As you can observe, this is calculated value is greater than the tabular value. So the calculated value chi-square is greater than the tabular value, and if it is greater, we reject the null hypothesis. Clear? We reject the null hypothesis H0, and therefore that is the nature of the work is not independent of the sex of the workers. So this is the conclusion, and there is a difference in the nature of the work on the basis of the sex, and therefore this is how we have to calculate the observed values, expected values, and we have to find out the degrees of freedom, and we have to find out the chi-square value. And this is the formula for test statistics, that is sigma oi minus ea whole square by ea. And this is the table, and clearly I have given each and every point in the table. Hope you all guys understand. So this is most important question on chi-square test of attributes, and definitely you can solve any problem of this kind. And if you really like, please raise your thumb, pass it on to your friends, and subscribe to this channel and stay connected. Thank you so much for watching.